Hello everyone, this is the other movie that I make in order to continue chapter 2. This is the last slide from previous movie that I made for you, and yes, this is about the histogram that talking about Q distribution. Okay, this is a Q to the right or Q to the left. And today we're going to use the other graph in order to present our group data. Group data in terms of frequency distribution data or table. Previous video we have looked how to make a frequency table by using 5 steps, and then when we have frequency table we can use we can construct or we can develop a histogram, and histogram is special bar chart that we use in order to present in order to show our frequency table. But histogram is a chart, frequency is a table, so they are the same thing but just one chart, one table. And this is the other technique for display or for present our frequency table by using the other methods of chart that we call frequency polygon. Okay, frequency polygon. Frequency polygon is a graph that consists of line segment connecting the points formed by intersection of each bit class. Okay, so a frequency polygon is a graph that consists of line segments connecting points formed by intersections of midpoint, class midpoint, and the class frequency. So frequency polygon is different from histogram. What is the difference? The difference is histogram use class on horizontal and class frequency on vertical, but frequency polygon not use class, it use class midpoint. Okay, so this is a little bit different from histogram. Histogram use class 1, class 2, class 3, class 4 on horizontal. Yes, on horizontal. This is vertical. On horizontal, histogram use a class, but frequency polygon use midpoint class or class mark that we already looked at so far. Okay, this is the difference. In a frequency polygon, the class midpoints are connected, are linked from one to next one by using line segment. Line segment is a line but with limitation, ending limitation, beginning limitation. If we're talking about line, no limitation, we don't know where is the end. Okay, but we're talking about line segment is a part of line, because when talking about line segment we have beginning and ending. This is line, but the line segment, because we have this is beginning point of the line, this is ending point of the line. We know that this end beginning, this the other end is ending of last. But if talking about a line no boundary, no limitation. We don't know where is the end. We are the end for one and the other one. But we're talking about line segment, we know segments. Segment is like a part. So a part of line. This is one part of line, the other part of line. Okay. In a frequency polygon, the class midpoints are connected to each other by using a line segment. The construction of frequency polygon, it is similar to histogram construction. Okay, It's similar to histogram construction. But I said earlier, it's different. Why is it different? Because histogram they use class on horizontal, but polygon they use midpoint class or class midpoint on horizontal axis. Additionally, find the midpoint for every class frequency. Okay, so first we need to look at similar to histogram construction, but more than histogram, you need to find midpoint of every class frequency. Then connect from midpoint of a class frequency to the midpoint of the other class frequency by using line segment. Okay, by using line segment. So how to construct, how to develop a graph of frequency polygon? Suppose that we have data from our previous example that about car sold, the price of car sold last month. Okay, the price of car sold last month, there were 80 cars sold last month with this price. So we have using 5 steps in order to make frequency distribution table. Then we have column 1, we have column 2, but we don't have this column. But in order to draw, in order to construct, in order to develop frequency polygon, we need to find midpoint. Okay, how to find midpoint? Maybe you still remember from previous video. Midpoint, maybe I put M, or you can put M, or you can put X, or you can put anything, but I just can put M. M1, the midpoint class 1. Midpoint class 1 come from H1 plus L1 divided by 2. That's why this is in thousand. Okay, in thousand. 21.55. It means that 21,555. But this say thousand is not comma, it's a point. Point that means a decimal. 21 point, not 21,000, because it takes thousand already here. That's why 21. Okay, so 21.555 come from 19 point, or come from, just both of them, add them together, divided by 2 in short. So class midpoint or class mark. Okay, so this is how to find. So how to find class midpoint? You can take L plus H divided by 2, or H plus L divided by 2 divide. It's the same thing. So in order to draw or construct frequency polygon, you need to find class midpoint together with frequency, class frequency. So in this case, in order to draw frequency polygon, we stop using class. Instead, we're using class midpoint and class frequency. Okay. So how frequency polygon is constructed, or is developed, or is made by using this table? To construct a frequency polygon, we use horizontally on graph the midpoint. Okay, the class midpoint. For example, 21.555, the first class midpoint. Then vertically is class frequency. Class frequency. Okay, class midpoint on horizontal, vertical class frequency. Then place a dot. A dot that means a point. A dot. The x and y values are this point. This point. You have a dot, for example. Yes, a dot. A dot that means a point. So on the graph, if you have one point, you need to have coordinate x and coordinate y. Okay, that's why x and y. A dot here with x and y. So x value and y values of this point are called coordinates. The coordinates of the next point are x 26.045, y 21. So this one. That's why this is x, this is y. We got a point. Okay. So how many points? Because we have 7 classes, you must have 7 midpoint classes, and you must have 7 class frequency. We use a class midpoint and class frequency in order to draw frequency polygon. Okay, how to draw it again? This one we already draw histogram. So based on histogram, we try to find class midpoint. Where is the class midpoint of the first class? This is first class, second class, third class, fourth class, fifth class, sixth class, and seventh class. Where is class midpoint? Class midpoint is exactly middle of the first bar for first class midpoint. Second class midpoint is exactly the middle of second bar, and on. Okay, I can find class midpoint here. Exactly the middle of bar 1, the first bar. Second class midpoint, third class midpoint, fourth class midpoint, fifth class midpoint, sixth class midpoint, seventh class midpoint. Okay, so class midpoint is already done. So first you need to find class midpoint. Then when you got the class midpoint for every classes, just use segment, line segment. Connect from class midpoint 1 to class midpoint 2, and then connect to class midpoint 3, and then connect to class midpoint 4, and next, and next. Okay, so all here. This line we call, this line connection we call frequency polygon. If I take histogram away, this graph only line like this one. This is we call frequency polygon. This graph we call histogram. Histogram is a special bar chart. Okay, but polygon or frequency polygon is a connected line segment from midpoint class to the other midpoint class. So this is the first class midpoint from table is 21.555, but actually in thousand. The last one is the class midpoint of the last class, 48.495,000. Okay, so this is we call frequency polygon. So again, how to draw frequency polygon? In order to draw frequency polygon, you need to find class midpoint. If you have histogram, it's easy to find class midpoint. But what if you don't have histogram, but you have frequency distribution table? It doesn't matter. You need to just put on horizontal. If you have frequency distribution table, you put class frequency, class on horizontal, and frequency on vertical. Okay, on vertical. And then you need to find the midpoint. Where is the midpoint? It is this point is beginning, this point is ending. Okay, midpoint around here. And midpoint is not here. This is the midpoint between class, but not midpoint class frequency. That's why you need to do a projection to the high of the frequency. Frequency of class 1 is 10. That's why this is class frequency. Class frequency of the first class. But it is the middle of the first class. Middle is in midpoint of the first class. Midpoint second class, the third class. If you don't have histogram, you need to have lower limit of first class, higher limit of class star, higher limit of second class, higher limit of third class, higher limit of the other class, higher limit of the other class, the other class, the other class, the other class, and you need to find midpoint, 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 midpoint. Actually, this one is not midpoint. Midpoint is the height of every class frequency. That's why 10. This is midpoint. This is midpoint, 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 midpoint. Okay, that's why you can connect from this one to 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 this one, this one to this one. Okay, this is a frequency polygon. But if you have, okay, if you have histogram, that easy, very easy compared with none. You don't have histogram. If you have histogram, you have a bar to find the middle, and then connect to each other. Okay, like to each other. So when I take histogram away, I still got a line, point and line. This line connection or line segment connection we call frequency polygon. This is the first midpoint class, the last midpoint class. But this is not good look. Okay, it's not good look like this one. This is from textbook. This is what I made. This is from textbook. It's not good look. It's like a mountain. Okay, this is mountain, but mountain fly in the air. Okay, fly in the air. That's why in order to make good look, I need to connect from the first class midpoint to the zero class midpoint. Actually, we don't have zero class midpoint. How to find zero class midpoint here? By taking the first class midpoint minus I. This is zero class midpoint. Actually, in our table, there are no zero class. Only class 1, class 2, class 3, up to class 7 as the last class. But you still can find zero class midpoint by taking the first class midpoint minus I. That's why this is connected. And this one also, this is the last class midpoint, the midpoint of the last class, and this is a fly in the air. That's why I need to connect it to the ground. So I need to find class midpoint or midpoint of the class after the last class. The class after the last class here. How to get this one? By taking class midpoint of the last class plus I. Okay, so this is completely calling frequency polygon. Actually, this is frequency polygon already, but it's not good look. It's like a mountain flying. You know, it's not good look. That's why I need to connect to zero class midpoint for the first class midpoint, and the last day here I find the other class midpoint. Okay, that's why this is good look. Okay, so this is the frequency polygon graph. Okay, frequency polygon graph of the selling price at 80 cars sold at this company. Okay, so suppose that I have two frequency polygons on the same graph. One is Widener, the blue one is Midtown, the black one. Based on your understanding, can you make conclusion about these two lines by posing the question: which car seller is the best or better behavior, better performance? Okay, whether the blue Widener or the Midtown. Okay, so I don't explain this one, but I'm waiting to hear your explanation for that graph by using your own understanding. Okay, so make me one paragraph by summarizing this one, which one is better. and white is better. For example, if blue light is better than black light, why? Or if black light is better performance or better sell than blue one, why? Okay, after you summarize this two frequency polygon on the same graph, go to cell review 2.5. Again and again listen cell review for you to practice. You don't need to submit me. Okay, you don't need to submit me. But if you want me to see, okay, you can. But it's not required you to do it to submit. But you need to practice it in order to get more understanding, to get a clearer understanding. This one that you need to do and submit. This is homework on page 41, page 42. Okay, maybe previous video I did not mention clearly what numbers that you need to do as homework. If you go to that page, the numbers or the exercise that you need to do as homework is even numbers. Okay, not odd number. Maybe you can see even number, any number that divided by 2, and we got integer result. Okay, integer result. So we can, if any number cannot divide it by 2, okay, those one is odd number. Okay, so again, this is your homework. And when is deadline? Your class on Wednesday. The deadline will be next Tuesday. Okay, next week Tuesday or next Tuesday. So do only, your homework is do only even numbers. Cell review, do it, but no, you don't need to submit me. But if you want me to see, okay, it's fine. What you need to submit is homework here, page 41, 42, even numbers. Okay, so this graph, what you need to do, write one paragraph, conclude about this graph, and doing cell review and answering exercise as a homework. Okay, and again deadline is on next Tuesday, and only even number. Okay, suppose that now we already complete and you got the point how to construct, how to make, how to develop frequency polygon. Okay, frequency polygon. But this slide is not frequency polygon, but it is about cumulative frequency polygon. Is it the same frequency polygon? Okay, not yet answer. Look at this first, because we already learned what is frequency polygon. But now cumulative frequency polygons, are they the same? Wait, not yet answer. Look at this first, and then you can answer. Cumulative frequency polygon, we can call the other less than cumulative frequency polygon. You know the less than, lower than. Okay, less than or lower than, less amount than, is used to determine, to check or to see how many or what proportion, how many we can count, what proportion in terms of percentage of the data values are below. You're talking about less than, below. How about above? You can talking more than. Okay, but because this is less than, that's why below a certain value, exact value or certain value or exact value. How about if you're talking about or if how many or what proportion of data the values above, this is not less than, this should be more than together with above, less than together with below. Okay, so a less than cumulative frequency distribution or a more than cumulative frequency distribution. That's why in order to study a less than or a more than cumulative frequency distribution, first you need to know what certain point that you base on. If you base on what point or what price that you base on, if you want to find less than that price, or you find more than that price, or below that price, about that price. Okay. The construction of a less than cumulative frequency polygon by using data from frequency distribution table like this one. Okay, this is selling price of the car. Unit in $1,000. This is number of cars sold, consistent with each price group, of the price. Okay. Suppose we were interested in how many of vehicles or cars that sold for less than the price of 28,290. So back to our frequency distribution, 28,290 is the higher price or higher limit of second class. So by looking at this one, how many car or how many vehicles that sold less than this price, you can count 31. How to get 31? 21 cars sold less than this price for second class, and 10 cars are sold less than this price because the first class is the price lower than second class. That's why this how many cars sold less than 28,290, we count the car in the second class together car in the first class, like this one. Okay, like this one. So how many vehicles sold less than this price? They are 31. 31 come from 10 from the first class and 21 from the second class. Cumulative frequency of a class, suppose that second class, is number of observation or vehicles or cars less than the upper limit of that class. That class is second class. Less than upper limit of second class. Okay, that's why 31. It means that there are 31 vehicles or cars that show less than selling price of 28,290. Okay, by looking at this one, cumulative frequency distribution for selling prices last month. This is selling price group or class. There are 7 class. This is number of cars sold. It depends on the price of the group. Okay, this is we already done so far. But now, how to find cumulative? In order to find cumulative based on the textbook, you need to add frequency from class to class to class to class together. For example, what is cumulative frequency for the first class? 10 come from cumulative of first class plus 0 cumulative of 0 class. Do we have 0 class? No, that's why 0. How about 31? How to find 31? 31 come from 31 from 10 from the frequency of the first class, 21 frequency of second class. Actually it should be 0 for 0 class, but we don't have 0 class, that's why we just not covering. Okay, so 31 come from frequency 31 cumulative frequency of second class come from cumulative come from frequency of the first class and frequency of second class together. How about 51? 51 comes from 10 out of first class. (21) out of second class and 20 out of third class. That's why we add frequency of three class together is cumulative frequency of the third class. And then you can see this will become longer and longer. This is based on textbook, but maybe I recommend you not to follow the formula from textbook because it becomes longer calculation. That's why I don't want you to make a longer calculation. Just make it short. Okay, just make it short. The formula cumulative frequency of the n class equal to cumulative frequency the class n minus 1 plus frequency of the n class. Okay, so I give you example. For example, if n equal to 6, so cumulative frequency of the sixth class 1, 2, 3, 4, 5, 6, 78. 78 come from cumulative frequency of 6 minus 1 is 5. 1, 2, 3, 4, 5, 74. Plus frequency of class 6. 1, 2, 3, 4, 5, 6, 4. That's why 74 plus 4 equal to 78. Or maybe I can give you the other example. If n equal to 3, 1, 2, 3, 51. If n equal to 3, n minus 1 is 2. 1, 2, 31. Frequency of 3. 1, 2, 3. 51 comes from 20 plus 31. Okay, that's why this is short. Textbook here tend to be longer from one class frequency to next class frequency. Your calculation tend to be longer. That's why maybe it's not a good method. That's why this is a good method. Any class frequency you need to use only 2 factor or 2 number. This number again and again. As I give example, if n equal to 6, you can see. If n equal to 3, you can see. Okay. This process is continued for all classes up to the last class. All world course, all cars were sold for less than selling price of 50,740. This is 50,740. It means all 80 cars, the price sold less than this price. Sold less than this price. No car sold more than this price. Okay. Okay, so I just replace this one by percentage, because in order to construct cumulative frequency or less than cumulative frequency, we use what? We use a frequency or we use cumulative frequency, and we use percentage, cumulative percentage. That's why in order to draw cumulative frequency polygon, we use class, we use cumulative frequency, we use cumulative percentage. Okay, this one we use. Okay, this call, suppose I use 3 of them. This is number of a castle. This is a percentage. This is about actually a cumulative number of castle. This is cumulative percentage of castle. Percentage of castle. So the first cumulative is only 10, but second cumulative is 10 plus 21. The third one, 31 plus how many? 20, 51. Okay, and add on and on. That's why this bar. Okay, that's why this bar. Or it's different from what? It's different from histogram. Okay, this bar is different from histogram. So again, I want to connect from bar to bar by using line segment. So this is the less than point. This is less than. In order to find less than, you need to take the higher limit. Okay, when you draw, it means that less than cumulative frequency, we tend to get higher limit. This is L1, H1, H2, H3. This is always H. H1 up to H7. Okay, because we're talking about more or less than. That's why we try to capture H. 8 to less than, 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 8 to less than. This is all H because we're talking about less than. Okay, that's why this is a lower limit of the first class. This is high limit of first class, high limit of second class, high limit of third class, high limit of the fourth class, high limit of fifth class, high limit of sixth class, high limit of seventh class. Okay, that's why we try to get this one. Okay, in order to connect from one to point, you need to have a point. Okay, you connect it. Okay, so this is cumulative frequency polygon. If I take bar chart away, okay, not taking bar chart away, I just find the other one. This is a should be okay. This one, what is this one? This one is A0, not L1. Okay, yes, L1, but we don't focus on L1. We focus on H, as I mentioned earlier. Always H here. That's why this is H0. How to find H0? H1 minus I. Okay, but it's equal to L1 because H1 minus I is L1, but we call H0 because we focus on H0. H, not H0. We focus on H, higher limit of each class. Okay, if I take the bar chart away, I got this one. Okay, this is always going up because cumulative is about additive, add up. Finally, when we add up all together, the finally is only 100%. If we add up all number of castle together, must be equal to total castle. Okay, last month the number of castle 80, total castle 80. That's why 80 is 100%. Okay, so this is based on a textbook, like the same thing, the same this one. This one will be easy for you to look. This one is from the textbook. So I have this one from the. This is like a projection from a number of car to the curve of or the graph of cumulative frequency polygon. This is from percentage to the graph and to the number of car. Okay, I can give you four points. Point A, this one. None of the vehicles, none of the cars sold less than this price. Okay, so less than this price. This price, so less than this price. How to get this price? This price should be L1. It should be L1, but I didn't say not that one, L1. It should be L1. This price should be L1, but why I take lower than L1 in order to cover? But you can take from L1. L1 that means 880. Okay, but I take less than L1 because in order to make it broader. But you can take L1. B, this B. B here, the B. This B, this A. This B, we can say that 25 of car or workhorse sold less than the price of 26,000. I just tend to be round up or round down, not to say something about this B, 26,000. Actually, relation to 26,000, not exactly, but because we don't know for sure this one. This is 30,000, this is 20,000, this is 25,000. Is it 26,000? Not really, maybe 26,000 something. Okay, but I just say 26. Maybe you can say 26,500 something because it almost or maybe 27 something. But I say 26 something. Okay, this is 525, 10, 20. This is exactly, this is 25. Okay, this is exactly between 20 and 30. This is right, exactly. But I'm not sure for this one. I just make a guess. That is 26. This is 25. This is 30. Maybe not 26. Maybe, let's say, based on this one, it should be 27,000. So for make sure you can estimate this one. I say 26, but maybe 27,000. Okay. The other one is C. Where is C? C this point. Not come from the number, but come from the percentage. Okay, come from the percentage. 50% of workhorse sold less than the price of 30,000. This is 30,000. This is exactly 30,000. Okay. 50% sold less than. Okay, 50% of the cars sold less than 30,000. D. This is D. 100% of the cars sold for less than the price of 52,000. 52,000. This is 50,000. This is 52,000. In order to make broader, that's why you can see this is lower than L1. This is higher than 87. In order to make it broader than. But however, you can take this is L1. You can take this is 87. It's not wrong. Okay. So this is how to let's say interpret. Interpret first. You need to look at you need to point the lowest one, nothing so less than this point, and nothing sold more than this point. Everything sold less than this point. Okay, and you can point maybe 2 or 3 between here to interpret. Okay, this is cell review 2.6. Cell review 2.6. Once again, this is for you to practice. You don't need to do it for submit. But if you want me to see, okay, it's fine. But if you don't, okay, it's also fine. However, this one you need to do. Exercises on page 45. Do only find solution only even numbers. Again, deadline is on next Tuesday. Okay, we will. You can check by your own. I don't know how many exercises from previous one and this page. Okay, it should be last point. A line chart. A line chart is often used to depict or display the changes in the values of variable over time that we call time series. If you have time series data, line chart is better. Okay, line chart better because what does mean time series data is 1 year to year, 1 period to period. Time values are labeled chronologically across the horizontal axis. Values of the variable along vertical axis. A line is drawn through data points. This line chart is also called time series line chart. For example, this one, I have data set. The course, this is the course, this is year taking, course title, this year student taking. For example, 2010, 35 students were taking this course, 1142, 1245, 1347, 1448, 1550, 52. That's why this is year. You can see this is time series because it's about 3 at a time, connecting from year to year to year. This is something that we want to study. Okay, this is we call line chart. Line chart normally used with time series data because it's easy to see the track or the movement go up and down. Which year go up, which go down? You need to find which one go up, which one go down. Why this year go up faster? Why this year go up slower? Or why this year go down slower? Or why this year go down faster? We need to find. We can see the track, or maybe the trend, or maybe the movement, or the direction of something that we study. Okay, this is summarize data, qualitative data, quantitative. If you have qualitative data, you can use bar chart, 3 types of bar chart, pie chart, or you can use, if you don't want to use chart, you can use table, we call frequency table. However, if you have quantitative data set, you can use histogram, cumulative frequency polygon, line chart, frequency polygon, or statement list. Actually, statement list is the other one, but I'm not covering this one. This is about chart. If you want to use table, you can use frequency distribution table. Okay. Misuses of graphs, especially line chart. One of the easiest ways to mislead the reader is to make a range of y-axis very small in terms of units. A second method is to begin at some value other than 0 on y-axis. Okay? This is misleading chart. Is wrong use. This is correct one. Maybe look at this one, and I want to hear your idea. Okay? So this slide asks you again. So I ask you to remember. I ask you to summarize. Okay, by one paragraph of what that you need to find. As I remember, this one. Summarize this one or conclude this one with one paragraph. And now, yes, summarize or interpret why this is wrong, why this is correct. Okay, this is time series data. Year. This is a sale in terms of sale revenue in terms of million. A line chart is wrong, B line chart is right.